Welcome everyone to the 11th lecture in the lecture series on circuits and system. I am Nikhil Kumar Nigam from EEE Department, Delhi Technical Campus. We will again start with having a recap of what we have discussed so far in the last lecture, and then we will move to the objective of today's lecture. If you remember, in the last lecture we were discussing about the classification of systems, and in that we discussed the static and dynamic systems. And on the basis of our discussion, we draw some conclusions. We discuss the system whose output is dependent on the time-scaled input are dynamic systems. Also, we discuss the the system whose output is dependent on the time-shifted input are dynamic systems. Then we discuss that the system whose output is dependent on the integration of the input are dynamic systems, and the systems whose output is dependent on the differentiation of input are dynamic systems. We classified system as static and dynamic. A static system depends only on the present input, whereas the dynamic system depends upon the past, present, as well as on future inputs. So we discussed that whenever we have a system which depends only on the present input, we say that system is static. But if we have a system which is depending upon past and present, or present and future, or past and future, or all of the three, then we say the system is dynamic in nature. We will see once again the numericals based on this static and dynamic systems. So these are some numericals we discussed. Let us briefly discuss them. As the output is dependent on the input, and the input does not have any kind of time scaling, time shifting, integration, or differentiation, so I will call this system to be static system. Similarly, in this we can see the output is dependent on input, but the input time is time shifted. It is delayed in time, advanced in time, so we will call this system to be dynamic system. This is dynamic system. In the same way, we can see output is dependent on the delayed input, so we will say that the system is dynamic. Now here we can see there is a scaling of input, but the scaling of input can be done, but the time scaling of input cannot be done. So if we have the scaling of input, then the system is static, but if we encounter the time scaling, we will say the system to be dynamic. Like in this example, we have output which is dependent on input and whose time is scaled, so we will directly say the system is dynamic. We have discussed how to solve these numericals in the last lecture. I am just briefly discussing over here Over here we have yt, which is equal to 1 minus xt. This means output is dependent on input, but the input is only simple input. The time has not been scaled or shifted, so I will say the system to be static. Now see here, we have this output which is dependent upon this factor and xt, that is, it is dependent on input as well as on a certain factor, but this factor will always yield a constant value irrespective of the value of t. So and we can see that the dependence of this output on the input is that the input is not scaled or not shifted, so we'll say the system to be static. Similarly, in this we can see the output is dependent on the time delayed, time advanced, and time delayed inputs, so the system will obviously be dynamic. dynamic system. In here the system is dependent on xt, which is not scaled, not shifted. So this part is saying the system is static, but this part is saying the system is dependent on time advanced input. So the system is, in all, the system is dynamic. So this numerical says that if the output is dependent on any kind of input which is time shifted or time delayed at any instant of time, then we will say the system to be a dynamic system. Then we have yt, which is equal to x of t plus 1. We can see the system has a time scale shifting input, so we will say the system to be dynamic. But here we can see this output, the input is time scaled, time shifted, but the same kind of shifting has been shown in the output as well. So if the same kind of shifting is there, then we will say the system is static. So this is how we determine static and dynamic systems. So in this lecture we will continue our discussion on different type of systems. So the next type of system that we have to discuss is the causal and non-causal system. Causal and non-causal system. In causal system, output is dependent on past, present, or both inputs. That is, the output is now will be dependent on either the past only or the present only, or on past and present inputs only. So in non-causal system, it is obvious that in non-causal system is dependent on future values, future inputs, in addition to past and present inputs. So we see the causal systems to be more practical systems, and non-causal systems are impractical systems. That is, the present output can depend upon future inputs. I must give you an example. Say a person has gone to a astrologer, and who sees the person's hands and predicts the future, and ask him to perform certain rituals in order to improve his future. Then the deeds of that person will depend upon his future. So that example could be an example of a non-causal system. So all the practical examples are the example of past, are the example of causal system which depend upon past and present inputs only. Previously we discussed the static and dynamic system, where static system depend only on the present values, and dynamic system may depend upon past, present and future, whereas the causal system depends upon past and present or present only, and non-causal system must depend upon future. There should be a future dependency of the output onto the future inputs. So if we are trying to synthesize a certain system, we can only synthesize system that depend upon past and present inputs. So in the subject we will be discussing the causal systems only, the synthesis of causal systems. Let us discuss some numerical based on the causal and non-causal systems. We have this example yt equal to 2xt, and we have to predict whether this will be a causal system or a non-causal system. As we already know that causal system depends upon past and present, so we will see how the output is depending on the input. So I will consider, say, time t equal to 0. If I consider time t equal to 0, then y of 0 will be equal to 2 times of x of 0, and let me take another instant t equal to 1. At this t equal to 1, y of 1 is equal to 2 times of x of 1, and in both the cases we can see that present output is dependent only on present input. Present output is dependent only on present input, and hence we can say that the system is causal system. Causal system. Let us discuss this one. Let us take the instant t equal to 0. At t equal to 0, we have y of 0 equal to x of 0. Now this equation is saying that the present output will depend upon present input. And let me change the time instant to -1. If I change it to -1, I get y of -1 to be equal to x of -2. Now this equation says that the present output will depend upon past input. This will be the past input in reference to this time instant. And similarly, if I take the time instant t equal to 1, then y of 1 will be equal to x of 2, and this says that the output, present output, will depend upon future input. So in all the three conditions, or all in all the three instances, we can predict that the output is dependent on, output depends upon present, past, and future inputs. Future inputs. So we can say that the system is non-causal system. System is non-causal. If we closely discuss these two, or if we closely notice these two, that there is no time shifting in this input, whereas there is a time shifting in it. So whenever a time shifting comes or time scaling comes, there is a time scaling. So whenever there is a time scaling in the input, the system will become non-causal. And if there is no time scaling or time shifting, then the system will be causal system. Let us discuss more examples. We have this example here where output is equals x of t plus 1. Now this shows that the output is dependent on an input which has some time shifting. So on the basis of previous discussion, I can directly say that the system will be non-causal, but still we should check it. Let us check at the instant t equal to 0 first. At t equal to 0, I'll get y of 0 equal to x of 1. At the instant t equal to -1, I will get y of -1 will be equal to x of 0, and similarly at t equal to 1, I will get y of 1 equal to x of 2. Now let me check that the present output is dependent on future input. Same here, present output is dependent on future input, because t equal to 0 is in future when the time instant is t equal to -1. Similarly, present output is dependent on future input here. So in all the three cases we can see that output is depending on the future values. So we'll say the system is non-causal system. Non-causal system. By non-causal means the system is practically not possible. It may be theoretically possible, but the system is not practically possible. So we can generalize this, that if we ever encounter a time shifting or a time scaling in the input, then we can directly say the system is non-causal. But still, in the university exams, you will have to solve the numerical just like this, and find out the result on the basis of your solution. Let us check this one. I can directly see that we have output which is dependent on xt, which is not whose time is not shifted or not scaled. We have another input xt minus 1, which shows that the time is shifted, and we have another input whose time is again shifted. So if we can, in the last we generalize something, that whenever we encounter a time shifted inputs, we can directly say the system is non-causal. So similarly, on the basis of this, I can say that system is non-causal. But still, let us see how to solve it. At t equal to 0, we will get y of 0 equal to x of 0 minus x of 1. This will be x of minus 1 plus 3 x of 3. Now this single equation is sufficient, because at the same instant we can see the output is depending upon present, past and future values, and I will directly say the system is non-causal system. Non-causal system. Let us proceed further. Okay, we are given here that we have a system yt which is represented by this set of equations, where yt is equal to x of t minus 1 for t greater than 0 and yt is equal to 0 for t less than 0. Okay, so it is obvious that yt is 0 for t less than 0. So if we want to check for its causality, we can only check for t greater than 0. So let us check. Let us have a value of t equal to 1. At t equal to 1, y of 1 will be given by this equation, and at y of 1, the equation shows that y of 1 is equal to x of 0, and at t equal to 2, we have y of 2 to be equal to x of 1. Now these two equations shows that the present output is dependent on past input, because in reference to t equal to 1, t equal to 0 is in past. So the present output is dependent on past input. Similarly, the present output in this equation is dependent on past values. So as the system is only depending on the past values, and I don't think anywhere we can encounter any output which can depend upon future values, so we will call this system to be a causal system. So the system is causal system. Similarly, let us check this. We again have a system yt which is expressed by these equations, that is y of t equal to x of t minus 3x t plus 2 for t less than 0, and yt is equal to x t minus 3 for t greater than 0. So whenever we are considering time instant, if we are considering time instant less than t equal to 0, we will consider this equation, and if we are considering time instant greater than t equal to 0, we will consider this instant. So let us consider at t equal to minus 1. At t equal to minus 1, that is t is less than 1, less than 0. So we will consider this equation. So y of minus 1 will be equal to x of minus 1 minus 3 x of 1. Now this equation shows that the present output is dependent on present input as well as future input, because in reference to this t equal to minus 1, we have 3x of 1 at t equal to 1 will be in future when we are considering the time instant at t equal to minus 1. So only this equation is sufficient to tell us that the system is a non-causal system. So the system is non-causal, that is the system is practically not possible. Let us have these two problems also. This particular problems appeared in the sectional exams 2 years back. Let us see this. We have y of t which is equal to x of sine t plus 1. We can clearly see that there is a certain shifting in time, as well as for x, this whole will represent the time instant. Not only this, but this whole will represent this time system. So we can clearly see that if it is a simple time instant, then this time will be scaled by sine. So we can say the system will be the non-causal system. Non-causal system because t has been scaled by sine factor. So on the basis of this, we can generalize that whenever the time of the input is scaled by any trigonometric quantity, if time is scaled by any trigonometric quantity, it will make system to be non-causal system. Non-causal system. The time of what? The input. The input time is scaled. See, in this example, we have yt which is equal to cos of t plus 1, x of t plus 1. So here we have time here and here. But in here, this whole is acting as, it will have a constant value. It will have a constant value, and this constant is being multiplied with the input. And when we are discussing that the time is scaled, then we are discussing only the scaling of the input time. So we are discussing about this, but over here, as there is no scaling, so we will say the system is causal system. The system is causal system, as there is no time scaling or shifting in the input signal. Similarly, this y of t depends upon, say if it depends upon t plus 1 x of t, then we can see that we have a factor which is depending upon time, but this is not an input. In fact, it is acting as a scalar quantity or scaled quantity which is scaling the input signal, and input signal time is not scaled or not shifted. So we will say this system is also a causal system. Causal system. We'll now discuss another very important classification of system as time variant and time invariant system. Whenever we are trying to synthesize a system, the system must be time invariant. Only time invariant system can be synthesized. Time variant systems cannot be synthesized. Let us first see what are time variant and time invariant system. I will define time invariant system, then automatically the reverse of it will be time variant. Let us see it. A system is said to be time invariant. It is said to be time invariant if any time shift in the input brings same amount of time shift in the output. That is, if we shift the input of the signal, then the same amount of shift should be processed into the output as well. Say we have this system. And when we input xt signal into it, it is producing a output signal of yt. Now if I delay the input signal or advances the input signal, see here I have advances the input signal by a factor of 1, then the system must produce a output which is also scaled by the same amount as the input has been advanced by plus 1. So the output is also advanced by plus 1. If this happens, then we will say the system is time invariant system. Time invariant system. And if say if I, instead of time advancing, if I produce a time delay in the input, then the same delay must be reflected into the output as well. That is, a time delayed signal must produce a time delayed output by the same factor. So if I advance the signal or delay the signal, the same advancement or delay should be reflected into the output. Then only then we will say the system is time invariant system. If a certain delay, say x of t minus 2 is delayed here, and it is not reflected in the output. Say in the output we have y of t minus 1. If we have a system where we input the signal and in the output we are getting this, then we will say the system is time variant system. Time variant systems are not synthesizable. Let us have a detail over it. To have more understanding of this time variant and invariant system, let us first have a bit of detail over the delaying and advancing of the signal. So we have a system which is acting as a delay. That means whatever signal I am feeding into it, say I am feeding a signal x of t, then it will cause a certain delay into the input, and then in the output the signal will be reflected. Say it is producing a delay of k, then in the output I will get x of t minus k. This minus represents that the signal has been delayed by a factor k. Now say if I have a signal of 2t inputted into the same system, and into this same system I am now inputting the signal x of 2t, and this signal will cause a delay of k into it, then what will be the output? In the output we will see now the time in the input signal is this whole factor, not only this t, but this whole factor is the time in here. So this delay will be reflected as x of 2t minus k. That is, this k has been shown as delay in this time, not only in this t but in this time. I mean to say that if I want to delay x 2t signal, then it will not be equal to x of 2t minus 2k. It will not be equal to this, it will be equal to this. Similarly, let us see, we have t plus t naught. Say I am inputting this signal now into the delay, which is causing a delay of k, then in the output I will get x of t plus t naught. This whole time will be delayed by factor k. See this, the whole time has been delayed by factor k. Let us also discuss the time advance. Say instead of delay I am now producing an advance. Say I have this signal 3t and it is being inputted into a signal which is acting as an advancer, which is advancing the signal by factor k. Then in the output I will get x of 3t plus k. 3t plus k, that is, it is pre-scheduling the time with by the factor k. Similarly, if I input the signal t plus t naught into this advancer, then I will get x of t plus t naught plus k. See here, this whole time has been, the whole time has been now shifted. Let us discuss one more example. Say I have x of sine t and I want to delay it by factor k. Then what should be the output? Let me write down some outputs. We have x of sine t plus k or x of sine t plus k. Which is the correct option? Think of it. See here, we have this input signal xt whose complete time is given by sine t, not only this factor or this variable t. The time instant is given by sine t. So if I am delaying it, then this whole time should get delayed. So if I consider this output, then this shows that only this t has been not delayed, it has been advanced. Sorry, let me say it is acting as an advancer. So if I consider this, then this shows only t variable has been advanced, but this shows that this time t, see this factor has been advanced by the factor k. That is, this sine t is different and this k is different. So this is the correct answer. Now when we have sufficient knowledge of delay advancer, let us rediscuss the time variant and time invariant system. Let us now discuss the concept of delay in output and delay in input. Delay in output. So we have a signal x of t which is fed into a system. Now this system will be producing its output yt. Now to create delay in this output, I will feed this output into a delay system. Delay. Now this delay will produce a delay of factor k. Then in the output I will get y of t minus k. So this is the delayed output. So how did we get this delayed output? Whatever is the time of the output, we have just delayed it by a factor k. Now let us see delay in input. Delay in input. Say we have a signal x of t which is first fed into a delay system, delay which is causing a delay of k. then in its output I will get x of t minus k, and then this t minus k is fed into this system, and this system, as this shows that this system is reflecting the input signal into the output signal. So in the output signal I will get y of t minus k. So this is the effect of delay in input. And now when this delayed input, that is the output due to this delayed input, is equal to this output, that is delay in output, then we will say the system is time invariant system. That is, delay in output is equal to the response produced by delayed input. If these two are equal, then the system is time invariant system. That is, for this system to be time invariant, this must be equal to this. So in short, how did we calculated the delay in output and delay in input? Let us discuss this with an example. Say I have a signal x of 2t. We have this signal x of 2t. So let us find out the delay in output first by a factor k. If I fed this signal here, then I will get, that is, I have the system where yt is equal to x of 2t. So if I am feeding the signal xt, I am getting yt. This yt is equal to x of 2t. Now if I am inserting a delay in the output by the factor k, then y of t minus k will be equal to, this will be equal to the delay in this signal, but the time here is 2t. So this will be equal to x of 2t minus k. See this, we have this time and this time here, and I have introduced a delay of k in this time only, 2k minus 1. So what has happened? I have introduced a delay in the input. So while discussing delay in output, what do we need to do? We need to provide delay in input. Delay in input only. And if I introduce a delay in input, then what will be the output? See, I'll discuss it here. If I have xt, then if I introduce a delay in here, I will get x of t minus k. And if I feed it into the system which is taking a certain input, and in the output it is getting the scaled timed off the input signal. So in the output, when I input this signal, in the output I will get y of t minus k, and this should be equal to the scaled version of this time, that is x of 2t minus 2k. X of 2t minus 2k. Are these two inputs equal? We can clearly see it is x of 2t minus k, and this is x of 2t minus 2k. This shows a delay in input is not equal to the delay in output. Hence the system is time variant system. Time variant system. And how did we calculated this delay? We just substituted the time, we just substituted the time t with t minus k. We just substituted t minus k in here. If I substitute t minus k here, I will get this x of 2t minus 2k. So while calculating the delay in input, we will substitute or replace we will replace t with t minus k, or while calculating delay in output, we will substitute delay in, not input, we will substitute delay in t only. This is the difference. And on the basis of this, if the output of these two processes are same, we will say that system is time invariant, and if the output of these two processes is not same, we will say the system is time variant. Let us perform some numericals, or we are running out of the time, so I'm giving these two numericals to you for your home practice. Perform yt is equal to 2 of xt and yt is equal to x of 2t at your home, and in the next lecture we will discuss these two numericals. Till then, thank you so much for listening to the lecture. If you have any queries, you can mail me your queries at n.nigam@delhitechnicalcampus.ac.in, or you can WhatsApp me your queries at 9215949494, or we will meet to discuss your problems in tutorials as mentioned in your timetable. Thank you so much. Take care.